Good evening everyone, welcome to the fifth video on one problem per day. This is for 11 marks and this will be the last video for this year because from next Monday onwards there will be a vacation. We will be starting on Christmas vacation. So as a result of it, I am not doing any videos. I know the people will be enjoying your vacation. I don't want to give you any homework or any burden that time. Okay, so we will begin once again the same set of videos starting from January 6th, I suppose. Okay, January 5th or 6th. So after you come back from the new year, we'll begin with this. Okay, so let us begin with this. So this question is for 11 marks. This will be published on 20th December. So the gravitational potential due to sun at its surface is given by, so this is your gravitational potential due to sun. Okay, Vs is given. The following data is available: mass of earth, distance of earth to sun, radius of the sun, everything is given. Okay, outline why gravitational potential is negative. What is the reason? So the first reason, because there are 2 marks, so I can say that potential. What is potential? Potential is nothing but defined. What is the potential at the earth? Potential at the earth is negative, and potential is, where is it defined as 0? Potential is defined as 0 at infinity. Okay, so therefore as a result of it, when you say it's an attractive potential, definitely potential has to become negative. Okay, this is one of the reasons. The second reason is that, see, you need to do some amount of work in order to take a mass to reach the infinity. Some amount of work has to be done to take or to move. Instead of take, you can say to move an object from surface of a planet to infinity. Okay, so how does this define it? Now if you ask me this question, I can see usually when an object moves from one end to the other end, or maybe something flows, okay, then definitely you can see that something flows. This will always flow from a higher potential to a lower potential, wherein you need not do the work. The earth itself, or maybe the planet itself, does some work. Okay, the planet will do a work whenever the object moves from a higher potential to a lower potential. Now if that is the case, let us say you are on earth over here, this is the earth, and let me assume this potential is V1 here, this potential is V2 here. Now if you want to move an object from V1 to V2, who will do the work? Is it you are doing the work, or the earth is doing the work? You only should do the work, right? So as a result of it, you are going against the earth's gravity. So if you are doing from here to here, if you are going from V2 to V1, definitely the potential is positive. Okay, if you are going from V1 to V2, that means you are opposite to the conventional direction. As a result of it, the potential is negative over here. Potential difference will be negative. Now let us move on to the next one. The gravitational potential due to sun at a distance r from the center is given as Vs. Show that r times Vs equal to constant. Okay, very simple problem. So what you do is gravitational potential due to sun at a distance r. So this is the sun, this is the sun at a distance r from here is given by Vs. What is the formula for Vs? Vs is equal to minus Gm divided by r. So what is he asking? R times Vs. Multiply it on the other side. R times Vs equal to minus Gm. Now you see, what is G here? The universal gravitational constant, which is a constant, 6.67 into 10 power minus 11. You already have this. Mass, what is M here? Mass of the sun. So when these two are not changing, definitely your R times Vs is always a constant. It's not changing, right? Okay, next one. So it's a very obvious question. Calculate the gravitational potential energy of the earth in its orbit around the sun. So this is the sun, this is the earth. The earth is now revolving around the sun in its orbit, and this is the radius. Okay, and he is asking you what is the potential energy at any point on its orbit. Give your answer to an appropriate number of significant figures. Now what is the potential? If this is the earth over here, let us say it's at P, then the potential Vp, okay, potential at P due to sun is given by minus Gm divided by r. Now what is this G, universal gravitational constant? What is M here? It's not mass of the earth, it is mass of the sun. And r is nothing but the distance from the sun to the point P, that is to the earth. Now let us see whether these parameters are given. If it is given, you can easily do it, right? Now look at this here. Mass of the earth is given, mass of sun is not given. So but if you look at this here, this minus 1.9 into 10 power 11 joules per kg is given. R is also given. See this R, so not this R, this R. Distance from the earth to the sun, this value of R is given to you. Okay, this is your radius of the sun and this is your mass of the earth. Mass of the earth, mass of sun is not given, but Vs is given. Now if you look at this, what is this here? Gravitational potential due to the sun at its surface, which means this Vs is equal to minus Gm divided by what? Divided by R, which are the small r over here. So therefore you have Gm is equal to minus R times Vs. Okay, I have been telling you every time the clue from the answer what you get from the previous question will form the input to this. Okay, so once again, so you see R times Vs equal to minus Ga minus Gm over here, M Es over here. So as a result of this, I can now substitute this as equal to minus R times Vs divided by R. I can write like this over here. Now what I will do is I will substitute the values of small r. What is the value of small r? Small r is nothing but 7 into 10 power 8, which is minus 7 into 10 to the power of 8 multiplied by Vs. What's the value of Vs? Vs is minus 1.9 into 10 power 11 minus 1.9 into 10 to the power of 11 divided by, what is the value of capital R? Capital R is the earth to sun is 1.5 into 10 power 11. Are you doing correctly? Yes. R and yes, minus 1.5 into 10 to the power of 11. So 10 power 11 goes away. So minus into minus becomes plus. So I will write this as 7 into 1.9 divided by 1.5 into 10 to the power of 8. Now let me use my calculator. Do I have a calculator nearby? I don't have a calculator. It's here. Yes, I have a calculator here. So I'll choose this as 7 into 1.9 divided by 1.5 will give me 8.86. 8.86 into 10 to the power of 8. What is the unit over here? What is he asking over here? Potential energy is asking. Oh my god. So this is only the potential. I want potential energy. What should I do to get the potential energy? Potential energy is M times Vps. This is your potential energy. Okay. So what I should do is, this M is nothing but mass of the earth. So what is the mass of the earth? Is it given? Mass of the earth should be given. Yes, it's given. 6 into 10 power 24. So I will substitute this. 6 into 10 to the power of 24 multiplied by 8.86 into 10 to the power of 8. When I do this, what is the answer I get? Once again, so I already have this 8.86 star 6. When I do this, I get 53.2. 53.2 multiplied by 10 to the power of 24 plus 8 should be 32, or I can now write this as 5.32 into 10 to the power of 33 joules, right? Energy. Okay, now the question is, he is asking about appropriate significant figures. Now how many significant figures are there? Now look at this. This is 2, this is 2, this is 2 here. It should be 2 significant figures. So what I should do? I should write this as equal to 5.3 into 10 to the power of 23 joules. This should be your answer. Okay. Next one. Calculate the total energy of the earth in its orbit. So now this is what? This is the potential energy. Okay. Now calculate the total energy of the earth in its orbit. Total energy is always equal to minus potential energy divided by 2, because it's already been bound to the earth, right? So therefore it is only half of this, and hence what I will do is I will just take this value 5.3 into 10 power 23 minus 5.3 into 10 to the power of 23 divided by 2, and I will calculate this value. So this should be 5.3 divided by 2, which will be 2.65. So this should be 2.65 into 10 to the power of 23 joules. So this will be your total energy. Okay. Then the next one. Now what is that next one? We have 2.65, but can we put in 2.65? 2 marks, right? I'll do like this. I'll put this as minus 2.7 into 10 to the power of 23 joules. This will be fine, because 2 significant figures, I need to keep it. Next one. Right. An asteroid strikes the earth and causes the orbital speed of the earth to suddenly decrease. Now, an asteroid strikes the earth. Okay, if it causes the orbital speed of the earth to suddenly decrease, if it decreases, what will happen? Suggest the ways in which the orbit of the earth will change. Now, it's already told you that the orbital speed actually decreases. if orbital speed decreases, then what will happen? The earth will have lesser kinetic energy. If it has a lesser kinetic energy, then what can happen? That means it gets a, so now it is moving like this. It's moving like this around the sun. So if it has lesser kinetic energy, it will now try to move towards the sun like this. It will now try to move towards the sun like this, right? So orbit of the earth will be near to sun, right? If it is nearer to the sun, which means what? Now radius becomes shorter, right? And then if radius becomes shorter, and at the same time what should happen is that, okay, it should be the force that acts on it, because if it is going in a spiral way, then there is a possibility that it may undergo a circular motion, or it could also become a motion like this. So earlier it was performing a perfect circular motion. Now what can happen when it is coming nearby? Now it may change its path like this. It may go farther like this. It may come like this. It may come like this, and so on. So as a result of this, this can even undergo something like a spiral motion like this also. So there is a possibility that the eccentricity of the path will also change. What do you mean by eccentricity? The shape of the orbit will also change. So this is also possible. Okay. So therefore you can say shape of the orbit may change. Okay. These are some of the things that can change whenever the asteroid strikes and it results in an orbital speed to decrease suddenly. Okay. Now let us move on to the next one. Outline in terms of the forces acting on it, why the earth remains in a circular orbit around the sun. Now here I said eccentricity or shape changes, right? But if that is the case, why should it always move in a circular orbit? If we ask this question, then when will a particle move in a circle? We already learned this in circular motion. If this is a center, and say for example I take a string, I connect a stone to this, and then if I whirl it across like this, so why will it move in a circle? It will move in a circle provided that the FD, what is this FD? Driving force is equal to mv square divided by r, where v is the velocity of the particle or speed of the particle, and r is nothing but the radius of the circle it performs. For example, if it is performing a circle like this, then what would be the radius? This would be the radius. Do not take this one, right? And if suppose if it is performing something like a circular motion vertically, like for example what we have here, then what can happen with the sun? This is your sun, this is your earth, then this will be your radius, and this will be your v over here, fd over here. Now what is this fd in case of gravitation? In case of this one, this should be nothing but equal to gmm divided by r square, okay, which is the gravitational force. Thus you can say, now what is he asking here? Why the earth remains in a circular orbit around the sun? The reason is because the earth would always try to go away from here, but the sun tries to pull it nearby to it. So why is it coming down like this? One is gravity, or gravity is the origin of the centripetal force. You can say since it is moving in a circle, centripetal force comes into existence, and as a result of it, so the path of the earth around the sun is always a circular in nature. Not always, okay, so it is seen to be circular in nature. Okay, thank you. So see you once again only after January 6th. So until that, have a happy vacation, enjoy your vacation, be safe, stay safe, okay, and do recommend my channel to all your friends, and ask them to subscribe, like and comment on it. Thank you.